Okay. So now we're dealing with right triangle trig. Some of this you've already seen in geometry. Right? We talked a little bit about it last year in Algebra 2 as well. But now you're going to do a lot of it. So you really need to understand things like 30, 60, 90 right triangles and 45, 45, 90 right triangles, the stuff that you have dealt with a while. We talk about this term standard position. We always will end up drawing triangles to the closest side of the x-axis. So when we start referring to things like the reference angle, it's always closest side of x-axis. If you start getting into the habit of drawing it to the y-axis, you're really going to get confused quickly, or you'll be doing everything backwards. So I would not recommend you try that. Go to the closest side of the x-axis. When we draw our angles in standard form, we measure, we talked about this the other day. We talked about this being 0 and this being 90 and so forth. So where would you find a 120 degree angle? Would it be in quadrants 1, 2, 3, or 4? Where would you find a 120 degree angle? 2, right? Because if this is 0 here and 90, it's going to be somewhere right here. 120 degree angle. And as we talked about earlier, we always drop that triangle side down to the closest side of the x-axis. What kind of cool triangle is that? Right triangle, amen. Which special right triangle is it? That's a 30, 60, 90, right? We got a reference angle of 60 right there. So we have a cool 30, 60, 90. That right there is your reference angle. Snacks? Okay. Okay, thought you got injured in your last class and it was an ice pack. Ah, okay. Yes, yes, your brain, your poor brain. 225 degree angle. Which quadrant? 1, 2, 3, or 4? Where's my 225 degree angle? That is quadrant 3, right? Okay, we eat those things in the hallway for a reason because they don't clean these floors but twice a year. So these things are disgusting. Then we have all kinds of insects. We clean the hallway every single night. All right, where do I draw the right triangle for this? Straight up. What kind of cool right triangle is that? 45, 45, 90. Whoa, 44. Who in the world let that dude in the room? 45, 45, 90 right triangle. And that is your reference angle. So any questions about drawing these, drawing the triangles, knowing what the reference angle is? Okay. So 3 of the next trig functions are going to be familiar to you, and 3 of them are not. Do you remember those 3? SOHCAHTOA. Exactly. Here, let's write that out. Over here. So what did this stand for? Sine is opposite over hypotenuse. Yes. And what about the cosine is adjacent over hypotenuse. You know, we're doing the standard definitions we've always done. And TOA, opposite over adjacent. Okay, that's all kind of stuff we already know. And, you know, knowing your reference angles, you know, you've got your angle measurement in here, and this one is opposite. The hypotenuse is always away from or opposite of the right angle, and that only leaves the adjacent one being next to it. That should all be fairly familiar to you. But, and can you tell me what the word reciprocal means? What does the word reciprocal mean? Don't use the word opposite when you want to mention the word reciprocal. I do know what you mean by that, but if you say opposite at a party, they're going to throw you out. Reciprocal. It means it's flipped over, right? It goes along with the idea of an inverse, right? It's an inverse in the world of multiplication. Okay, now, sine has a reciprocal function, just like cosine and tangent. They have reciprocal functions, and you are now going to be introduced to those. Enough of that. So cosecant goes with sine. These two go together. And we abbreviate it CSC. In fact, I'll just let you write these down. Secant, abbreviated SCC, not Southeastern Conference, for you football fans. Cotangent, abbreviated COT. If you want to write that stuff down, that's fine. I have a cool way to remember it, but you do need to know what the words are and what their simple abbreviations are. CSC, SEC, COT. You got them written down? At least, you know, the word and the abbreviation? Okay. It's all being recorded, so you can come back and watch it later. Cosecant goes with sine. Now, if these are truly reciprocal trig functions, what happens to the O and the H? They switch. If secant goes with cosine, what happens to the A and the H? If cotangent goes with tangent, what happens to the O and the A? Ladies and gentlemen, may I introduce you to the reciprocal trig functions, Choshika. Choshika. I can T-pose at the same time if you want. Choshika. Okay, goes with Sokotoa, folks. It's already out there. It's already out there on the internet. I mean, you got to have proper neck position. It's everything. Probably, yeah, go ahead. That's the dumb way I try to remind myself what the reciprocal trig functions are. Now, when I was in high school, I had to try to remember which trig function went with which one. Well, what I noticed was they always started with the opposite letter. Am I up to billions yet? Use. Now I'm going to say this. If you can't figure out which one cotangent goes with, you are in a lot of trouble. But I do understand the words secant and cosecant, and you're trying to figure out which one it goes with. Well, just remember it always starts with the opposite letter. So if we're talking about cosecant, we know it goes with sine because it starts with the opposite letter S. Okay. Now we need to do some of this with a 45 degree angle triangle. All right, so, whoops, we'll move that, lock it in place. That's a terrible looking 45, 45, 90. Let me try that again. Not much better, but oh well. Suppose the hypotenuse of a 45, 45, 90 is the number 1. Do you remember back from your geometry days, how do you go from the hypotenuse to one of the legs? Something to do with radical 2. Do we multiply? Do we divide? What do we do? If you multiply by radical 2, which is a number larger than 1, you would get a value bigger than 1. Do you want a value bigger than 1 for the side? No, don't you want something smaller than 1? Because we know the hypotenuse is the largest side of a right triangle. So you'd have to divide by radical 2. Of course, nobody at a party would leave it like that. Okay. We would rationalize it. What do we get? Radical 2 over 2. So, when you're at a party and referring to that, you want to use radical 2 over 2, which is the exact same thing you get on the other side. Because it's an isosceles right triangle, correct? We'll make this our reference angle down here in the bottom corner. What is the sine of 45? We know that this is the opposite side, this is the hypotenuse, and this is the adjacent side. So what is the sine of 45? Sine. So. Yeah, but nobody on the street or at parties would refer to it as 1 over radical 2. They would, radical 2 over 2. So wise for your young age. What about the cosine? Come on, adjacent over hypotenuse. Same exact thing, right? What about the tangent of 45? Opposite over adjacent. 1. Anytime you divide by the same thing, you get 1. So now if I want to find the other three, yeah, don't tell them. Cosecant, secant, and cotangent. And I really did not leave myself enough room here. What are we going to end up with? I'll give you a few seconds to figure it out on your own, and then we'll see if we agree. They will equal each other, but they don't equal radical 2 over 2. Okay, so what are we going to do each time? You're going to flip them over, right? So 2 over radical 2. Don't you have to rationalize that? Does anybody know what the denominator ends up being? Isn't that just 2? Okay, so is anybody going to, have a panic attack if I do this? Because I just got rid of it, right? I don't need those. So the only thing I'm left with is this. Okay, so what are we going to get for secant? The exact same thing. And please tell me we can do cotangent. 1! Thank you very much. I was really hoping we weren't going to have a hard time flipping that over. Any questions about those? I know the reciprocal trig functions are new to you, but all you're doing is flipping them over. So now we got a 30-degree reference angle. We're not done yet, are we? All right, thank you. So if the hypotenuse is 1, how do we go back to the short leg of a 30, 60, 90? Divide by something, but it's not radical 3. Good try. Divide by 2. Now, what would I multiply by to get to the long leg? Now you pull the radical 3 out. Okay? If I multiply 1/2 by radical 3, I get radical 3 over 2. So we've got the opposite, we've got the hypotenuse, we've got the adjacent. So sine 30, cosine 30. Let's see if we can do this quickly and get these knocked out before the end of our day. Figure out those, and then we'll go to cosecant 30, secant 30, cotangent 30. So that's fine. Yeah, and you're right, exactly. What do we got for the sine? 1/2. Incidentally, let's go over to the right here. Give me the cosecant that goes with it. 2. How about the cosine of 30? What's the cosine of 30? Radical 3 over 2, right? Adjacent over hypotenuse. And when I flip that over, 2 over radical 3, you know, when I'm going to this one, rationalize it, what do we end up with? 2 radical 3 over 3. Yeah, it's a little crazy. How about the tangent of 30? Opposite over adjacent. Now I'm going to write this out here. Opposite over adjacent. And you notice that I'm writing it horizontally like we might have done in junior high, because this reminds me of that whole thing, keep, change, flip, right? 1/2 times what? 2 over radical 3. Does anything cancel? The 2's. Giving me 1 over radical 3. And if we rationalize that one, we get radical 3 over 3. Now, I'm going to circle something here. This is the equivalent. What I'm circling right now in red is the equivalent of radical 3 over 3. We know that they are exactly the same. Now, isn't it easier to flip over 1 over radical 3? What do you get when you flip over 1 over radical 3? You get radical 3. I know the 3 reciprocal trig functions are new to you, but they're not really that difficult if you understand it's just the reciprocal. Flip it over. You just have to remember which one goes with which. Thank you for participating with us today.